CSC 480 Artificial Intelligence 1. This is assignment 2, dots and boxes. And here's the game. So the first thing you need to do is enter a board length. I'm going to do a small one, so I'm going to enter 2. This is a 2 by 2 board. The depth, I'll do 4. It's just how many moves in advance the AI will look. And so here's the layout of my board, and I have to enter in a move, and basically you enter in row, column, and then the wall. It is left, L for left, T for top, R for right, and B for bottom. So I'm gonna play the game real fast. So 1, 1, L, that places a left wall here. The AI placed right here. The AI placed a left wall on 0, 0. So 1, 1 bottom, and the AI will almost beat me every single time. It's really tricky to get it to work, but it's really the algorithm's too powerful for the game really. So there you go. I just put one there and I scored 4 points, but then he just scored 5 points. So now the game score is -1, so he's gonna win. Um, left. I'm placing a left wall there, and the game is over. He destroyed me, -7. So that's the game. I'm gonna quit. You can play again after the game is done. So I have these helper objects right here, and so I have a board, and a board just holds an array of squares. And here's a square. A square. This is basically a quad tree. So there's pointers to left, right, top, and bottom. The problem is if I add a wall on one of the squares, the adjacent square needs the corresponding wall. So if you add a left wall on a square, if there's a square to the left of that square, you need to add a right wall on that. So that's why I set up a quad tree for my board, and it has a layout of boards, and then it just saves the length of the board for yeah. And then there's this node. I am building a PCS tree, which is what I use for my min-max algorithm. I also have a custom stack, and that's this pointer. And this node just basically holds a board, and then all these data, a weight, the depth, the move data. If I'm pruning, if this node is going to be pruned, I'll set it to ignore. I'll set that as true. And then is it a min node? Is it a max node? That's this. That's the player. And this is just an enum. And the wall, yeah, go here. The player's an enum, min max, and the wall's an enum, left, right, top, bottom, and that's the node right here. And then the node stack is real simple, push pop, and is empty, so real easy. Dots and boxes. Here's where all the work is really getting done. I set a new game. I can try to make a move. I determine if the game is active. Calculate the score, and print the board. And those are the public functions available. Let's look into some of these. So like trying the move. This is where all the work is done. If the move is valid that I type in, then it will make the move and print everything to the screen. Then the AI moves. So the AI will construct this tree using the min-max algorithm, using the depth first search algorithm with, but it will not go past the play depth. So once it hits that, it stops, and it will keep expanding these nodes. Oh, and also if the node has been pruned, it will be ignored. So on this expand node, basically it's kind of ugly. It just loops through all available moves on that node and sets up all of these children trees. And if the board is big, it's really gonna take a while. It really goes on and on and on. So that's what this does, and it's pretty large. So after this, we expand all the nodes, and once this tree is built, oh shoot, it can get pruned. Yeah, here. So I can prune a node, and I just mark the nodes as ignore. And if they're marked as ignored, I don't do anything with them. So that's that. After the tree is constructed, I then determine the node, and it's pretty easy. I just take the root and I loop through all the children, and the child with the lowest weight, the least weight, basically wins, and that's the move that gets actually applied. So there's that, and then after this, I clean up the tree. I just basically destroy everything. Yeah. And that's really it. If you make the board too big, and if you make the depth too big, it's gonna really lag. So I stick around maybe 4, maybe 5 at most, and then the depth. If it's 5 depth, don't, or if it's a 5 by 5, don't make the depth too big. And if it's a 4 by 4, generally anything past 4 by 4 and a depth of 4, it will start lagging. So anything before that is okay. And yeah, that's the assignment.